Alright, so I'm going to tell you about a little bit of Salsa-CI. How many of you saw Augustin's talk in the morning? Half of you. So some of you might know a little bit already what I'm telling. I'm going to tell you briefly about Salsa in general, and then I'm going to tell you how we are using it in the MariaDB packaging. It's fairly extensive. Alright, so personally I'm very hyped about Salsa. I like Git, and I like Gitlab, and I like CI, and I'm very happy that in the recent 2 years it has gone pretty quickly, that Debian got this new infrastructure and it's being utilized very well. So Salsa is Debian's own GitLab instance. How many of you have used Salsa? How many of you have a user account for Salsa? Alright, not everybody. If you're a Debian developer, you absolutely should do that. So it was prototyped in 2017, and it started, the beta was launched in December 2017, and then it got pretty quickly pretty popular in the beginning of 2018. And it's run by the Salsa admin team. And in the MariaDB and MySQL packaging team, we moved all of our repositories in January 2018 to Salsa when the beta was on. That was a no-brainer. And Salsa-CI, that is run by the separate team. They are making a custom pipeline that's specific for Debian packaging. And according to the Git logs, Augustin made the first version last summer, and since then it has been rapidly evolving. And I've also done some patches for it, and I was a member of the team at some point. And in MariaDB, I learned about Salsa-CI in DebConf last year, and then I put all the major MariaDB repositories using it immediately. So it has been going on for a year about now. Alright, so I'm thrilled about it. I think it's amazing. So it saves a lot of time, and it does all the testing that the Debian infrastructure will test anyway on your package. So now you get the feedback on every commit or every time you push to Salsa. Salsa-CI, it builds the package, so you know it builds, the source is correct, and the whole chain from the upstream, how that the upstream source is correct, that it actually builds, and that the Debian packaging is correct, that it actually builds the Debian packages. Then it runs the error log checker, which you can see if you go to tracker and look at your package. You can see the build log notifications from there, but you can also run it yourself with this tool, BLHC, and that's included in the Salsa-CI pipeline. Then there's repro test for testing that the builds are reproducible, and auto package test. Obviously, most or many Debian packages have had auto package test scripts for a long time already, and you can see the results on ci.debian.net. But now with Salsa-CI, it will be run for your package on every push. And then there's of course lintian, and if you get lintian errors, it will flag the commit, and pew parts testing installs, uninstalls, and upgrades. This is the scope what Salsa-CI currently does. And so I think it's amazing. This is what it does, and these are the benefits you get. So with Salsa-CI, you can. I've done a couple times the mistake that I've done some very minor change, and then I upload, and only after upload I realized that there's something gone wrong, and then I, like 1 day after that, re-upload with minor changes with a small fix. So now I've got rid of all of those kind of stupid, unnecessary upload cycles. Also, if you upload to Debian, it will take a couple of days for new lintian results and others to appear. Now, when using Salsa-CI, you will get the results pretty much immediately. Also, when you do this testing during your development, the package that you end up uploading will be of higher quality, and you will probably do less uploads, and that will save Debian archives disk space, and it also will save your end users from having to spend time doing unnecessary upgrades. It's also great that when you have the pipeline, anybody who forks the repository can use it, and this means, among others, that people who are contributing to your package can also run this before making a merge request. And for yourself, it's very, very nice to look at the statistics and the build logs and see that everything is green. So at the point when you actually do an upload to Debian, you can be pretty confident that everything will go well. And since everything is fully automatic, it will save you a lot of time, and you will feel much more productive using CI. All right, so what does it look like in practice? It's very easy. In the Galera 3 source package, we are using Salsa-CI exactly as everybody else are using Salsa-CI. So you don't have to put lots of pipeline code in your project. All you need to do is have one file, YML file, which then has this includes, that it includes 2 files from the Salsa-CI pipeline. And the rest is then automatic. And then you can extend this. For example, here you can see that I have on the master branch, I have the basic version, and on the buster branch, I have an additional variable defined, so that when these tests run, it knows that it's testing for something that will be uploaded to buster. It's very simple. And once you add that file, then you need to go in your repository settings under CI. You will find this. You can define the path to GitLab, to the CI Gitlab-CI config file, and then you need to make sure that you have a runner enabled. Runner is the thing that will actually then execute the stuff that is inside that YML file. If you don't change the custom CI config path, then GitLab will by default use .gitlab-ci.yml from the project root, and that of course doesn't apply for any Debian packaging because you're only allowed to do changes under the Debian subdirectory. Maybe, I don't know, maybe the Debian Salsa admins could change that it would be globally a different default path. Right, so once you have that going, you will then see in the UI the CI pipeline going. So here are some screenshots. So this is the front page of the repository. And then you have here CI. And the network seems to be a bit slow. And then you can see the CI running under this section. So here are 2 screenshots next to each other. This one is from the pipeline. You will see what commit it is testing, and then the subject of that commit, and then you will see the stages. By default, there are 2 stages in Salsa-CI, and then you see the individual jobs inside those stages, and then you see a green or a red mark, or sometimes yellow, depending on the result of the test. And then you can click on these to see more information about the job. And here is one job that is open. This is the build job. So here you can see the log. And when it's building, you will see the blog in real time. It's scrolling all the time, so that's very nice compared to other build systems. And when it's done, there will also be some artifacts, and you can define what you want. By default in Salsa, there will be the packages that were built. So you can take the deb files built by the CI and test them manually if something went wrong or so. So it's very, very nice, and it's very easy to learn because it's graphical. You just click around and browse, find all this stuff. And there is the address if you want to go and check out what it looks like for Galera 3. Also, when you have the CI enabled, you will automatically get these green marks in many other places as well. For example, from the point on when you enable Salsa-CI, in the commit log, you will see after each commit that has been tested if it passed or not. And when people make pull requests, if they have the runner enabled, you will see the test result for that pull request, or in GitLab terminology, it's merge request. By default, this will not prevent you from pushing anything if the tests fail. So this is just a feedback system. It's not a gatekeeper in any way. You can do your own configuration to do that. But by default, Salsa-CI only gives you feedback. It doesn't prevent bad commits from going forward. Yeah, and then you have all kinds of other nice features that are built in GitLab. You get, for example, notification emails when your builds fail, so you don't have to remember to manually check the result. If it fails, you will automatically get an email. And you can also integrate it with IRC, and there's webhooks and stuff, so you can get the results in many nice ways. So this is Salsa-CI in a nutshell. Do you have any questions at this point? And those who saw Augustin's talk in the morning already knew everything so far. All right, so this works very well for a simple package and most of the time for complex packages as well. But MariaDB is far from a simple package. Therefore, we've done lots of our own custom stuff. So first of all, MariaDB is a very big package. It's at the time it's 13 million lines of code, and there is the main code, which is in C++, and then there are lots of script stuff. The testing system is written in Perl. Then there are different kind of modules and sub-projects and Git sub-modules and whatnot. It's a very old project. It's like over 20 years old and huge in size, the source size, and then also the Debian package itself is quite huge. It has something like 150 files in the Debian directory, and from this one source package it generates at the moment 25 binary packages. It's the main server and client packages, and then client libraries and plugins and MariaDB backup and others. So it's quite big, and it's not just that the package itself is quite big, it's also quite a complex landscape, because upstream keeps making new releases. There was MariaDB 5.5, then came 10.0, 10.1, 10.2, 10.3. Now a couple months back we got 10.4, and every time you get the new upstream release, you will have something will be different. From every upstream release to another, there will be something different. And it's not just about tracking all the upstream releases, but also whatever went downstream. So you will have in parallel many versions that you are maintaining. Here is just for the MariaDB server. You can see that in old stable there's 10.0, and then there's in stretch 10.1, and in Buster 10.3, and soon there will be in Unstable 10.4. And then on the right side you see the same result from Ubuntu, that there is 10.0 in Xenial and 10.1 in Bionic, and then there is 10.1 in Cosmic, but it's a different 10.1 because it was released at a later time, so it's based on a different version. And in Disco there's 10.3 and EOAN 10.3 as well. So there it's like a huge matrix of all the upstream versions and then what releases they went into. So there's lots of, and every version is slightly different, so there's lots of things to track. You easily get confused if you're working, if there's for example a security release and then you need to do lots of downstream releases, you easily get confused if there was some difference somewhere or was it or not. So automatic testing is a huge help here because you can run the tests on the actual distributions that you're targeting. All right, and then also this is a database, so it's not just about updating the binaries and runtimes on the systems, but you also need to consider that people have configuration files. This is the default configuration you get by simply running apt-get install MariaDB, and then people can go and edit all of these configuration files and add their own configurations. Then on the right side you see a part of the content that is in the database from a default installation, and obviously the data is something that users will add their own data. They might move around the path where they have the data. They might have the data on some special file systems and stuff, and really the target environment can be, there's a huge variation of what kind of target environment people have, and then when you do an upgrade you basically need to do it in a way that in every single installation you will not break the configuration and certainly not break the data. There's lots of opportunities for things to go wrong. And also it's a big package and it also has lots of users. At the moment in Debian popularity contest it says that 30% of the submitters have either MariaDB client or the server or both installed because they have the MariaDB common package. So it's a huge user base, and if you screw up something and ship a bad update, then there's lots of people who will get angry at you. So really testing and good testing is very nice. All right, so what does the custom pipeline look like then? So we have 18 jobs running in 5 different stages. And this is really small, you probably don't see, but I will go through each stage. So the stage 1 is the build. So we are building the, let's say this is for the master branch that is targeting, that will be uploaded into Unstable. So before you upload it to Unstable, you will see the CI results if it will build in Unstable or not. And in addition to building in Unstable, we are also building in stable, so we know that if this is packaged this way, is it possible to also backport it? So we are automatically building a backport on every commit. And if this would be the Buster branch, then it would test if the package builds in Buster and if it can be backported to Stretch. So the CI is always, it knows what branch it's run in and what is the target distribution that it will be uploaded to. So building is stage 1. And then stage 2 is that we take the built binaries, the artifacts from the stage 1 is left behind. You have the binary packages, and then you do testing on those binary packages. And the idea is to find out if something is obviously broken. It does a simple fresh installation, it runs auto package test, and auto package test itself will spin up the server and do some commands and some SQL queries to ensure that it actually works. And the auto package test also runs the upstream test suite that has like hundreds of unit tests. And then we run lintian, and then we have a separate run that does some basic features, starts up the server and runs some basic commands to ensure that the server as it is installed in Debian with the exact same service files and everything actually works. Then stage number 3 is upgrading. So if this is the master branch, then it will check that if you upload this commit to unstable, will an existing unstable installation upgrade without problems. And people can have the server installed, or people can have just the client installed, or people can just have the client libraries installed. So that's why we have 2 upgrade scenarios that we are testing here. And then step number 4 is testing the upgrade from the stable release or the previous stable release. So if this is the master branch targeting unstable, then it will test that people who have been running stable, if they would now install the version from unstable, will it install correctly? This is basically testing also in advance what would happen in this upgrade situation. So we're not testing just if it works in SID, but also we are testing what will happen eventually when there's a new stable release and lots of people will upgrade from stable to the new, from the old stable to the new stable. And we're not just testing the stable upgrade, we're also testing if people are running any old stable version and then upgrade to this version. So for example, here we are testing if people are running MySQL 5.5 in Jessie and they upgrade to the version that is in this commit, will it work or will it not? And then we also had things like, for example, there used to be a separate MariaDB connector C package in MariaDB 10.1, but in MariaDB 10.3 it was merged into the same source package, and the package names changed slightly, so therefore we have a separate testing that if you are in this scenario, will everything work for you when you upgrade? All right. And then in step 5, we are doing some additional tests which have a lower priority. So for example, we are testing like if you have MySQL 5.7 that is currently available only in unstable, if you have that installed and then you install this version that was in this commit, will it work? And then we are testing the log information and PO parts, and then testing client library upgrades. And the reason why we have these 5 stages is that if the build fails, then it will immediately stop here and it won't waste any resources on the Salsa system, because obviously if the build fails, then none of the other tests can be done, and we don't care about build log errors or stuff at that point. And then when it tests quality, if we can see here that a fresh install in unstable, for example, is broken, then it will abort testing at this stage and it will not try to do the upgrade testing or any advanced testing, because that's kind of pointless in a situation when you know that out of the box the basic installation is already broken. So this is the reason why we have different stages. Right, so then I'm going to show you some of the snippets from the tests themselves. So I showed you that the Salsa-CI or Gitlab-CI, it's just a YML file, and inside the YML file you define some custom language that is specific for Gitlab-CI, but most of the time you just do shell scripting inside this YML file. So the script part in this test is a little bit special. So here we are testing that if people are running the libmysql client libraries from the MySQL source package and they upgrade to MariaDB, what will happen? So what this test does, first we install all the MySQL client libraries available in unstable. Then we check with package config what libraries it sees. And then we start with apt install, individually installing different libMariaDB client libraries and compatibility library packages. And if after each installation we run package config to list that what libraries and what names and what versions it is seeing. And then at the end we are running ldconfig as well to see what kind of results they have. And then in the build logs you can see what the result was, and this grep will obviously fail if you're not seeing either one. And in these tests also, if everything went well, you will get some results with all of these library names. So if this breaks, then obviously something is wrong with the library names. There's no chance for people to use them correctly. And here is another test, which is slightly more complex. So instead of just inspecting what libraries we shipped, we actually take one consumer and build that using our library. So in this, we've selected the MySQL client Python package. So it doesn't have any adaptations for MariaDB at all. So that's a good example, good canary to use. So what we do is we install the libMariaDB client libraries, and then we check with package config what kind of MySQL client names it sees. And we are installing this includes the compatibility libraries which will have libMariaDB, but it will use the libMySQL name, so that libraries that have no adaptations for MariaDB at all will still work just out of the box. Then we install pip, and then we install MySQL client package, and this will automatically do the compilation because of how the setup file is inside that Python package. And then we can remove the build dependencies so that we only have runtime dependencies left. And then we actually execute a small Python line to check that you can load the MySQL library and it prints out the sensible information about the client. So this is really useful, and we didn't have this before. And when we migrated from libMariaDB 18 was the package name to libMariaDB 3 globally, there was lots of problems, and they were kind of hard to get because users in production or in running environments would not immediately see those problems. Those problems would be visible when you rebuild something, and usually that's developers doing that. And when developers have problems rebuilding something, they don't believe that the library itself is broken. They will just find some way around that. So the problems were quite subtle, and few people were reporting them to us. But with this test, we now consistently test for this on every commit, and we were able also to use this test to convince upstream how things are supposed to work, so that everything goes without any additional manual work or adaptations in the libraries. You have a question?
Maybe you can just repeat my question. So why do you pip install instead of using the build package?
So we pip install.
Repeat my question.
Yeah, so the question was, why do we use pip install? Instead of using the Debian package. So we use pip install because the Debian package is, I think, already built. So pip install actually fetches the MySQL client package from pip as source and then builds that on your system. And it doesn't have any Debian adaptations or any MariaDB adaptations at all. So this is kind of a, we're taking something that doesn't have any doesn't have any adaptations. So if it works, then we know that 99% of everything will work. Yeah, but the crucial thing is that it actually builds the package during pip install. All right. So I don't know how well you can see my screenshots and text here, but everything is visible. So you can just go to the MariaDB team on Salsa and check out the pipelines yourself and check out the Gitlab-Ci.yml file and see exactly what it does. And I like this a lot, that the test code is kind of explicit in the same repository where the source is also. So if you're doing some changes to the source, which are supposed to change behavior, then you can in the same commit also adapt the tests that they test for the new behavior. And then you don't have breaking tests at any point. And also if you have breakage in the tests at the point when you don't, when you were not expecting to have any breakage, then it's very easy to debug because it's basically just shell scripting, and you can take all of these commands and copy paste them on your own computer. And Gitlab-Ci works that it runs Docker images, so you take the same Docker images as the starting point and then copy paste the same shell script lines in there, and you can very easily replicate the exact situation and the exact environment that caused the problem. Sometimes I've come across problems that something doesn't work properly on Debian Q&A systems, but then when I do a similar test on my own computer or on some test environment, everything works. So something is different in the details of the environment. And that kind of differences in details of the environment is kind of gone now when you can exactly take the exact same Docker image version and run the exact commands line by line. It's also much easier if you have breakage to report to upstream, because for upstream it will be evident, or they can more easily, it's more transparent what the testing is doing, because you have the kind of the source of the testing in the same place. You don't need to start researching Debian infrastructure more. Yeah. Do you have any comments so far? Yeah.
Why it's working? Okay. Why you are using Gitlab for the test instead of using auto package test, like another test case inside there? Just for some test cases, I guess it's going to be much better than doing a job there, but not sure.
Yeah. Well, I'm not sure if you. So there are usually restrictions in auto package test environments that you can't, for example, spin up new containers or virtual machines to get a clean system and then test installs and upgrades as freely as you want.
Well, honestly, I don't know either. But yeah, I think that is going, it should be better doing the test part inside of auto package test. But just as a comment. And another question is why you're using the upgrade testing? You are doing that by hand, like you customize that, but why PurePart doesn't fit there? I think PurePart does already have that feature, like upgrading from stable to testing to unstable, and
Yeah, well, what we're doing in this installation and upgrade tests, that we're not just doing the installation. So PewParts only cares about if you're leaving files around. But PewParts doesn't test if your service actually starts, or if it runs, or if it responds to some API call or something. So that's what we're interested in. We're not just interested in if it installs the files and removes the files. What PewPart is interested in, we are interested in if it actually works and runs. So that's why we kind of do these steps separately. And also, auto package test and PewParts are very big and slow tests. So having as separate tests some of this stuff that in theory could be embedded inside those will have kind of a usability benefit, that it will run faster and you will see the name of the failing test immediately on this level. And sometimes you have problems that the bigger your test, like kind of single chunk is, like auto package test or PewParts, the more likely it is that you have problems that are not actually related to the installation itself or the test itself, but something about the environment or permissions or timeouts or something like that. So then you can see here if for example fresh install works and upgrades work, but PewParts fail, then you know it's some kind of corner case in PewPart, or the PewPart infrastructure or the tooling is broken and not the actual installation and upgrading.
Good, thanks.
Have you had cases where all was green here, and I'm looking particularly at the DEP8 results, and then when you finally upload, it fails in those tests, in the DEP8 test, for example? Like how similar is this environment to the
This
real
is very
one?
reliable. If this is all green, then everything's going to be all green on Debian systems as well. Because this is using fresh Docker images that have the fresh repositories exactly as they are in Unstable. So if you run these tests and then you upload on the same day, you will have an exactly identical situation in the official archives. Yeah. All right. So here are listed some of our, we'll get some more questions soon. So here are listed some of our challenges and peculiarities, which I'm going to go forward because it kind of tangents what you were asking. So we need to do more testing than what the basic Salsa-CI includes. We could maybe refactor our code or our testing code that we would have include the Salsa-CI like the base and then add our own tests. But at the moment the structure is that we have defined all of the tests ourselves and then we manually sync with what Salsa-CI does. And there are some interesting stuff. For example, MariaDB is a service, and if you're running a database service and you do an upgrade and the service restarts and fails to do that, and then the service is down, then that's a major production problem for you. And this is, for example, something that PewParts doesn't test, and we want to test if the service correctly restarts and that the systemd files are correct and so on. And actually in Docker you don't have any systemd by default, so we have this our own little intervention here that we are enabling systemd by doing a sed to the policy rc.d file, and after that apt-get install will actually activate the systemd services that the maintainer script tells it to do. Then also the limits of Gitlab-CI has been a major problem because the package is so big that building it takes a long time. But luckily we got CC cache working, and CC cache changes have also been upstreamed into Salsa-CI. So now everybody using Salsa-CI will benefit from CC cache, which means that when you're compiling C code, it will not compile the same files if the underlying source files have not changed from the previous compilation. And then also there's a limit that the maximum build log can be 4 megabytes, and when you build MariaDB, it will be way longer than that because it's such a huge package. So what we're doing, we're hiding the output from the build and just tailing the last 10,000 lines. And then also because if you have a completely silent terminal during the build, then GitLab will terminate that, assuming that it timed out or something like that. So we are spawning in the background a process that will every 10 minutes say just that 10 minutes passed. So this is we have all kinds of small hacks here and there to get this working. But I've been very pleased because in the recent months it has been quite stable and worked very well. Yeah, and you saw one yellow circle in the results. That is that in May this year, for some reason, our upgrade test from Jessie to the latest version started failing because the udev package complains about an unrecognized option, and this is completely unrelated to MariaDB, and I haven't figured out what's wrong with Jessie, why udev is broken there. And then the reproducibility builds are on, but the results are not honored because RocksDB and TokuDB currently are not reproducibly built, and that will make the test fail. So that's something that should be fixed, and it's kind of hard to fix, so I hope somebody would help with that. And other things, so this is kind of the bug side, and then the new feature side on the right is obviously that we could extend the test suite to do more advanced testing, because we know that the end users have very heterogeneous environment. They have different data, different configurations, different systems, so we could have a little bit of more noise in the test system of different scenarios, different user scenarios. And also regarding the slowness, I've been thinking about putting up a custom runner that would be very fast and only run MariaDB builds with PCIe hard drives and stuff. But I'm not sure if that's a good idea, because if the tests require that you have a really fast runner, then if the test gets slow, then other people can't reproduce the same tests because they don't have the same runners. Yeah. And now the talk is over. We still have time for questions, right? Yeah. So you can come and ask me afterwards, and that's my Twitter handle. I'm going to post the slides, the link to the slides there. And there will be also a BOF session on Friday. Will you, Augustin, be able to attend? Good. About Salsa and Salsa-CI in general.